Hello friends, welcome to my channel. So in this video we will see the various types of cement. So initially we will cover these four types of cements: rapid hardening cement, low heat cement, sulfate resisting cement, and finally we will see blast furnace slag cement. So our first type, it is rapid hardening cement. But before going into the details of rapid hardening cement, we will see two basic properties of cement. First one is setting of cement and other one is hardening of cement. So in the setting, whatever our fluid or paste, it get converted into the solid form. Okay, so whatever our cement paste is in the fluid or paste state, it get converted into the solid, then we term it as a setting of cement. And in the hardening, whatever that solid paste we have got, that start gaining the strength. So in the setting, it is simply change into the fluid or paste to the solid state, and in the hardening, along with the solid state, it start gaining its strength. In the last video, we have discussed about some box compound which are playing important role in the rapid hardening cement. So we will quickly revise it here. So first box compound that we have seen is tricalcium silicate, then dicalcium silicate, then tricalcium aluminate. Okay, so the properties: tricalcium silicate, it gives early strength, then dicalcium silicate, it is responsible for later strength. Okay, later strength, which is generally occurs after the 7 days. And tricalcium aluminate, it gives instantaneous strength or quick strength. Okay, now we will move towards the rapid hardening cement. So in this cement, the rapid hardening is required, that is the gain of strength required is quite rapid or quick. To achieve the rapid hardening, we kept the box compound in such a way that the proportion of tricalcium silicate, which is responsible for the higher strength or early strength, it is kept in the higher proportion or higher content, and tricalcium aluminate, which is responsible for the early strength, it is also kept in the higher proportion. But as we know, we require the rapid hardening, so the proportion of dicalcium silicate, which is responsible for the lower strength or latter strength after 7 days, so in the rapid hardening we kept dicalcium silicate in the lesser proportion. Along with keeping this proportion, the two more things are done in the rapid hardening. First one is addition of calcium chloride, and along with that we do finer grinding. Okay, so finer grinding is done in the case of rapid hardening cement. So this is about the basic composition to produce or manufacture the rapid hardening cement. Now we will see some properties of the rapid hardening cement. Okay, so first one, we will see the setting times. Okay, setting time, so its initial and final setting time is same as OPC, that is initial setting time is around 30 minutes and final setting time is of 10 hours or simply 600 minutes. So as we know that their setting and hardening both are the different properties. Setting is just the change in the fluid state or paste state into the solid state, so that's why initial and final setting time is same as OPC. It does not impact, that means using of rapid hardening cement does not cause any changes in the setting time as rapid hardening. So hardening is just the process of gaining the strength. Okay, so setting time is same as OPC. Then we will see the strength factor. Okay, strength. So whatever the strength that OPC cement gives you in the 7 days, it is obtained in the rapid hardening cement only in the 3 days. Okay, so whatever strength is obtained from OPC by using OPC in 7 days, it is achieved in the rapid hardening cement only in the 3 days. So this is the main advantage of using the rapid hardening cement. Now we will see uses. So uses, first one is absolutely it is rapid hardening, so used for urgent repairing works. Then quick removal of formwork, for the quick removal of formwork. And the next use is it is used in the cold weather concreting. Okay, in the cold weather concreting. Okay, so shortly we will see what is meant by cold weather concreting, what is exactly it is. So concreting is generally on the weather basis, we can classify it as hot weather concreting, and second one is cold weather concreting. Okay, is cold weather concreting. The difference is very simple. Hot weather concreting is done when the temperature is above 40 degrees Celsius. It is termed as the hot weather concreting, and whenever we work in an environment or in the temperature which is below the 40 degrees Celsius, then we term it as the cold weather concreting. Okay, so this is all about the rapid hardening cement.